Hello everyone, welcome to another YouTube channel. So, in the last video, we have seen section A of the class 12th examination of mathematics subject, which is conducted on March 9, 2024. In this video, I'm going to solve section B. Okay, so section A was consisting of the question based on MCQs and assertion reason based. Okay, so they are 1 marks type question, and in this section B, you will get 5 questions of 2 marks each. Okay, so 5 questions and 2 marks each, and they are total. Let me show you the total questions. 22. There are two options in 22. Either one of them you have to do. 23 single based, and 24 again you have internal choice is given. Then 25, and then 20. 25. Okay. So there are total 5 questions in these sections, and each questions carry uh, 2 marks. So this section will get total of 10 marks. Okay. Okay. So again, let me give you the brief introduction of the whole question paper. In the last video, I've already given. Just let me revise it here shortly. So you can see question paper consists of 38 questions, and there were 5 sections. You can see here section B I have written 10 marks. Okay. In the subsequent videos, we will solve section C, section D, and section E. Let's come back to section B and start looking at the question, and then we'll see how to solve section B. Yeah, here it is, section B. Section B, as I have told you, carry 10 marks, and these are subjective based question. You have to write the answers of this question in detail solution form in your answer sheet, and for each step you will get uh, different marks. Okay, so there is stepwise marking also, and there if all the steps are correct and all the answers are given rightly, then you will get the full 2 marks for each question. The first question here, it is given from the chapter of application of derivatives. Okay, so we have also seen various questions in MCQ uh, from section A based on the chapter of application of derivatives. So application of derivatives is very important chapter, and for this chapter you should know the basic knowledge of continuity and differentiability. Okay, and only then you can solve the question based on this topic. So let's read the question. The question is saying the volume of a cube is increasing at the rate of a 6 centimeter cube per second. How fast is the surface area of cube increasing when the length of an edge is 8 centimeter? So here we have to find the surface area increasing rate, that means ds by dt, and in the question dv by dt is given, and we have to find ds by dt at particular length when edge length is 8 centimeter. So how to solve this question? So first I have drawn here a simple cube. I think you should already know, there is no need to draw this. Just for the simplification of solution, I have drawn this. So if I assume the edge length as x, the volume will be v is equal to x cube. Okay, and the surface area is equal to 6x squared, simple surface area and volume formula. And if v is equal to x cube, then you have to differentiate v with respect to time. Okay, but v is a function of x, so first we have to change uh, here a variable. So dv by dt we got by first differentiating dv by dx, and then x is a function of time, so we have to differentiate again x with respect to time. Okay, that is dx by dt. So we will write dv by dt is equal to 3x square into dx by dt. The question dv by dt is given as 6, so if we put the value here, we will get finally dx by dt as 2 by x square. Now come to the equation of surface area. Surface area is given as 6x square. I mean, it is not given, but you can easily remember the formula of surface area, and here it is surface area. Okay, you don't have to get confused whether it is lateral surface area or total surface area. So when nothing is given, you will take total surface area. Okay, the total surface area of the cube is 6x square, and again surface area is a function of x and x is a function of time. So first we will differentiate s with respect to x, and then we differentiate x with respect to t. So ds by dt will give us 12x multiplied by 2 by x square. That is ds by dt is equal to 24 by x. So this is the general expression of ds by dt, rate of surface area change. Okay, uh, but we are asked to find ds by dt at x is equal to 8 centimeters. So put x is equal to 8 in the above expression, you will get 24 by 8, and corresponding to that the rate of increase of surface area will be 3 centimeter square per second. Let me correct this value. It is it should be 3 centimeter square per second. Okay, because surface area is in centimeter. So it's very important that you should write unit also correctly and the magnitude should also be correct. So I think 2 marks should be divided point 0.5, point 0.5, point 0.5. Okay, so point 0.5 for the correct answer, point 0.5 for the ds by dt, and point 0.5 for the dv by dt, and point 0.5 for dx by dt. Okay, so it's a average question. If you know the concept of application of derivative, you could have done this question very easily in the question paper. Okay, in the exams. Let's go to the second question of section B, that is 22. And in this question, we are given options. So either you have to do part A or part B. Okay, you will get full marks for any of the two parts. Okay, but here I am giving the solution for both the parts so that you can easily decide which part you have to do or which part you have to leave. Okay, but you will learn different concepts if you solve both the questions. So this question is asked from the chapter of inverse trigonometric functions. Okay, so again, inverse trigonometric function is directly related to the chapter of trigonometry, which we have studied in the class 11. So to solve this question, you should know some basic concepts, some basic formulas, some basic identities related to that chapter. Okay, if you don't know, then you won't be able to solve at least part A. Okay, you can solve part B partially, but that also requires some concepts of 9, 10th, and 11th. Okay, so let's start with the part A. So part A is saying that you have to express tan inverse cos x upon 1 minus sin x in the simplest form. You have to very carefully look at the inequalities given here. Inequality is that minus pi by 2 less than x, and x is less than pi by 2. Why is this given? Because when you have to at last cut tan inverse with tan, that cancellation is only possible when we are in the principal value branch of tan inverse. Okay, otherwise if you cut that without without taking x in its principal one, that's not possible, and you won't get full marks. So first simplify. Before tan inverse there is a bracket, and in bracket there is expression. So you have to first of all convert this expression somehow in the form of tan, then only this tan inverse will get cancelled. Okay, so how to do that? So cos x we can write as cos square x by 2 minus sin square x by 2, using the formula that cos 2 theta is equal to cos square theta minus sin square theta by 2. So you have noticed that when it is 2 theta here, and this will get half. Okay, so when this is x, so half of x will be x by 2. Okay, and similarly half of x here, and in the place of 1 we can write a very useful thing using trigonometry, that sin square theta plus cos square theta is equal to 1. Since all the x has to be converted in x by 2, you will use cos square x by 2 plus sin square x by 2. Although you can write cos square x plus sin square x, but that won't get you very useful result. So for making it a formula, you have to write cos square x by 2 plus sin square x by 2 only. And in the place of sin x, you can write 2 sin x by 2 cos x by 2 by using the formula sin 2 theta is equal to 2 sin theta cos theta. Again, you have to keep in mind when 2 theta is in RHS, you have to get reduce it to half on the sorry, when 2 theta is in LHS, you have to reduce half of that angle in the RHS. Okay, so half of x will be x by 2. That's what we have done here. Okay, now there is a simple algebraic calculation further. As we know, a square minus b square is equal to a plus b into a minus b, and a square plus b square minus 2ab is equal to a minus b whole square. So if you put all this and use this identity, you will get in the numerator as tan inverse cos x by 2 plus sin x by 2 in one bracket multiplied by cos x by 2 minus sin x by 2 in another bracket upon cos x by 2 minus sin x by 2 whole square. Okay. Now 1 cos x by 2 minus sin x by 2 will get cancelled from numerator and denominator. Now in the numerator we are remaining with cos x by 2 plus sin x by 2 minus cos x by 2 minus sin x by 2. Now take cos x by 2 common from both numerator and denominator. So sin x by 2 has to be divided by cos x by 2 because there is no cos x by 2 with sin x by 2. So when sin x by 2 is divided by cos x by 2, it will become tan x by 2. So that's what you getting here. 1 plus tan x by 2 upon 1 minus tan x by 2. Now in numerator with tan x by 2 you can write 1 because it won't change its value, because there is a purpose to write 1 here, since we know that tan pi by 4 or tan 45 degrees is equal to 1. So in the place of 1 if we write tan pi by 4, and in the place of 1 in the denominator also we will write tan pi by 4. So we will reduce this expression within the square bracket as tan of pi by 4 plus x by 2. Now this is the form which we are trying to derive. Okay, and at the last you can easily cut tan inverse with tan, and this cancellation is only possible when the value that is inequality of x lies between in the principal value branch of what that is tan inverse. Okay, otherwise this cancellation would have not been possible. So answer will be pi by 4 plus x by 2. This is the simplest form of the question that we are asked to find. Now, coming to question number 22b. So again this question is from inverse trigonometric function. So for this question you should remember what is the principal value branch, that means domain and range of the all the inverse functions. So I have already written here. So we are going to need tan inverse, cos inverse, and sin inverse. So you should know this value, you should know this value, you should know this value. And along with that you should also know what is the particular value of sin theta, cos theta, tan theta at standard angle, that is pi by 6, pi by 3, and so on. Okay, pi by 4. And along with that you should also know what are the sign of t ratios in um, various quadrants. So I've already drawn this. In quadrant 1 all are positive, quadrant 2 only sin and cosec are positive, in quadrant 3 tan and cot are positive, in quadrant 4 cos and sec are positive only, rest are negative. So you don't have to draw all this table. I just drawn to make this solution look simpler. You have to do just this calculation what I have done beside this. So tan inverse 1 is a very standard principal value branch, that is pi by 4, because tan of pi by 4 is equal to 1 directly, and pi by 4 is a principal value for tan inverse, so no need to change that. Cos inverse minus half is not lying in the principal value branch, because minus cos pi by 3 is equal to minus. So how to make this a principal value? So we should know that range of cos inverse is 0 to pi. So we have to make such angle for which cos inverse or for which cos become minus half. So as we know cos pi by 3 is half, so if we put minus in front of that it will become minus half. So how to make minus cos pi by 3 positive? So take that angle in the second quadrant, because uh, in second quadrant, once yeah, in second quadrant cos is negative. Okay, so to make that angle uh, in second quadrant, we have to subtract pi by 3 from pi. So we will get cos to pi by 3. So for cos to pi by 3, we will get minus half, because 2 pi by 3 means 120 degree. 120 degree is second quadrant angle. The second quadrant angle will give us negative value. So that means cos inverse minus half is 2 pi by 3. Okay. And for sine inverse minus 1 by root 2, again minus pi by 2. Pi by 2 is the principal value branch for sine inverse. So just make minus sine pi by 4. So you will get minus 1 by root 2. Just take the minus sign within the uh, what bracket, because sine of minus theta is directly equal to minus sine theta. Okay. So here we will get sine inverse minus 1 by root 2 as minus pi by 4. Okay. Now put all the value in one single line, that is pi by 4 plus 2 pi by 3 and minus pi by 4. So minus pi by 4 plus pi by 4 will get cancelled, will remaining with 2 pi by 3 or 120 degree. Okay. So the correct answer for this question is 2 pi by 3. Okay. Now let us go to question number 23. 23 is a question again based on application of derivatives, and it's very simple question. This question is directly asked from the exercise of NCRT. It is asking that it is not asking exactly, it is actually asking us to prove that given function is an increasing function of x in 0 to pi by 2. So what to do in that kind of question? So if function is increasing in some interval, then in that interval its f dash x should be greater than 0. Okay. So all we have to do, just find the f dash x and then show that it is decreasing in 0 to pi by 2. So here fx is 4 sin x upon 2 plus cos x minus sin. So there are two terms. So first term we will differentiate with the quotient rule, that is u by v, that is differentiation equal to u dash v minus uv dash upon v square. So what I have done already here, 4 sin x differentiation is 4 cos x, and kept the denominator constant here, then minus sign. Now kept the numerator constant, differentiate 2 plus cos x, which differentiation is minus sin x, and upon 2 plus cos x whole square. If you simplify this expression at last, you will get mm, something 4 cos x minus cos square x upon 2 plus cos x whole square. Now take the cos x common from here. You will find f dash x as cos x into 4 minus cos x upon 2 plus cos x whole square. And this expression is greater than 0, because in the interval 0 to pi by 2 cos x will be positive, because these are first quadrant. In the first quadrant cos x is positive everywhere, and cos x maximum value is 1. So if we subtract 4, if we subtract 1 from 4, we will get positive only, and square of anything is positive. So this is positive, this is positive, and this is positive. So everything is positive. So positive upon positive will give us positive value only. So f dash x is greater than 0 if we take x in the interval of 0 to pi by 2. So this proves that uh, fx is an increasing function in 0 to pi by 2. Okay. Let's come to question number 24. Question number 24 is asked from the chapter of continuity and differentiability. Again, there are two options. Now, in there two options, 24a is asking that if y is equal to cos cube bracket sec square 2t, we are asked to find dy by dt. So let's solve first question. So the first question is asked from the topic of parametric differentiation. In parametric differentiation, y is not written directly in the form of or as a function of x. Rather, it is written as a function of t or something else variable. So it is not difficult but lengthy problem. So if you do step by step, the answer will come in very few steps. So I've already done the differentiation. Just look at the differentiation and you will simply understand it's not that difficult. So if we differentiate y with respect to t, so y is given as cos cube sec square 2t. So cos cube sec square 2t can be written as cos sec square 2t whole cube. If we put sec square 2t as, let us say, capital X, then it will become cos x cube. And in the place of cos x, if we write y, then it will become capital Y cube. So capital Y cube will simply be 3y square. So 3y square means 3 will come here. Y square means cos square x, and in the place of x you can write sec square 2t. So first differentiation will be like x cube. Now next differentiation will be of cos x. Cos x differentiation is minus sin x. So here I have written minus sign, and in place of capital X you have to write sec square 2t. Next differentiation will be of x. So x is sec square 2t. X is sec square 2t. So sec square 2t can be written as sec 2t whole square. And if we take this as let us say z, so x is z square. Z square differentiation is 2z. So I have written 2 sec 2t. After that you have to differentiate z. Z is sec 2t. Sec x differentiation is sec x tan x. Then I have written sec 2t into tan 2t. And at last we have to differentiate 2t, and 2t differentiation is 2. So just rearrange all the terms we have got. You will get final answer as minus 6 cos sec square 2t into sec sine 2 sec square 2t into sec square 2t into tan 2t. What I have done, just multiply 3 minus 3 and 2, you will get minus 6, and 1 2 you can make it shorter by combining 2. So for this combination we have applied the formula of sine 2 theta. Sine 2 theta is equal to 2 sine theta cos theta. So this is a very moderate question. I would not say very easy or not very difficult, but moderate question. So here just the answer is very important, because you should write answer as simplest as possible and as correct as possible. So I think correct answer should be minus 6 cos in bracket sec square 2t multiplied by sine in bracket 2 sec square 2t multiplied by sec square 2t multiplied by tan 2t. Okay. So this is one of the part of 24. Another option is given within the question number 24, that is 24b. So let's solve 24 part B. This question is based on, again, application of continuity and differentiability, and the topic is logarithmic differentiation. This kind of differentiation always require log to differentiate. So x to the power y is equal to e to the power x minus y. So take log on both sides. Exponent will come in front of log. That is property of log. So y log x will become x minus y into log e. So log of e at the base e will become 1. So you will get the expression as y log x is equal to x minus y. From before differentiating this, we can also write uh, y as x upon 1 plus log x. Okay, if we take y on LHS and taking y as a common, so either you differentiate this equation or differentiate equation 1, you will get the answer from both the equation. So I've done using the equation 1. Y differentiation is dy by dx. Log x we will keep constant, and then plus sign, and we'll keep y constant. Log x differentiation is 1 by x minus y differentiation is 1 minus dy by dx. We have applied product rule here. You can see I have written formula here also. D by dx of uv is equal to u dash v plus uv dash. Now take dy by dx on LHS. And taking dy by dx common, you can get a factor of 1 plus log x. And in the RHS 1 minus y by x, put the value of y from the above in this equation. And rearranging this all the terms on one side and keeping dy by dx on LHS, you will get the answer as dy by dx as log x upon 1 plus log x whole square. So we are asked to prove that dy by dx will be log x upon 1 plus log x whole square. Okay. Now come to the last question of section B, that is question number 25, and this question is asked from the topic of integral, and that too in the subpart definite integrals. So we are asked to find the integration of cos x into log 1 plus x upon 1 minus x dx with lower limit minus half and upper limit plus half. So this question is asked from the topic of definite integral, and using the property of definite integral we can easily solve this question. If this question would have asked in indefinite part or indefinite integral, this question would be very difficult and I think not be very easy to solve. Okay, so we can easily apply the property of definite integral. If you can remember, there was a property like this: if limit is from minus a to a over integral fx dx, so this gets reduced to two things: either 2 times of 0 to a fx dx or simply 0. So this 2 times will become when function is even, and this 0 will become when function is odd. So we can check the nature of fx by putting x by replacing x by minus x. So I have done that. If you put minus x, then f of minus x will become cos of minus x into log 1 plus bracket minus x upon 1 minus bracket minus x. So cos of minus theta is equal to plus cos theta, so cos minus x will become cos x, then log 1 minus x upon 1 plus x. Now a by b can be written as b by a inverse. So just within the bracket of log, just inverse the numerator and denominator and take the power of minus 1. This power of minus 1 will come in the front of log, and if we take the minus sign overall in the front of cos, you can see this is becoming minus of fx. Okay, because fx is cos x into log of 1 plus upon 1 minus x. So it is very easily seen that fx is an odd function. There is no need to integrate this question. You can easily write, since fx is an odd function and since the limit is from minus a to a where the value of a is half, the value of integral will be 0. So the answer for this question is 0. So this question was simply just to check whether you know the property of even or odd function. This question was not about calculating the integral. Okay, so sometimes they put the question in a different chapter, but that chapter do not belong, so that question do not belong particularly to that chapter. There is some simple logical questioning also involved. So this question is very perfect example of that logical reasoning. Now this completes the section B of the question paper, and in the next video we will take questions of section C. Okay, and try to solve section C. Okay, so let me give you the starting line. So from here we have started section B, and from the last video we have solved section A. Section C carries 18 marks, section D carries 20 marks, and section E carries 12 marks, for which we will solve the questions in the subsequent videos. Okay, so thank you for watching this video and have a nice day.